Hello children, till now we have done ionization energy and now we will start from electron affinity. Okay, so electron affinity is the amount of energy released when an extra electron is added to the valence shell of an atom. Okay, when an extra electron is added in the valence shell of an atom is called electron affinity, and after the gain of electron the atom will change into negatively charged ion, that is anion. Okay, so when electron is added to the valence shell of an atom, then it will form negatively charged ion, and this is called electron affinity. Okay, let's take one example to understand this. We will take one example of chlorine atom. Okay, see what is happening here. Chlorine atomic number is 17 and electronic configuration is 287. Now when it's in its valence shell, you can see 7 electron is here. So to get its octet or to complete its octet, it need one electron. Okay, and one electron is added here in a neutral atom or in a gaseous atom. So after addition of one electron, it will form negatively charged ion, that is anion, and the electron configuration will change to 288. Okay, and here this cross is representing the extra electron that we have added to neutral atom. So when electron is added to neutral atom, energy is released. Okay, energy is released after gaining of electron. Energy is released by an atom. This energy released is called electron affinity. Okay, in some book you can see that electron gain enthalpy is written. So electron gain enthalpy and electron affinity both are same thing, only the difference is the name. Okay, so one more time, just see here. Neutral atom is here, one electron is added, and after the addition of electron it is changing into negatively charged ion, and when electron is gained by atom, then you can say energy is released. This energy released is called electron affinity. Okay, energy released is called electron affinity. See here, when we are moving from top to bottom, that is in group, then what is happening? Size of an atom is increasing. And when we are moving from left to right, the size of an atom is decreasing. Okay, so like ionization energy, electron affinity also depends upon nuclear charge and size of atom. Okay, so as we move down, what is happening? The size of an atom is increasing. Okay, and nuclear charge is also increasing, but due to increase in this size of an atom, the distance between nucleus and the valence shell is more, so there will be very less attraction between nucleus and valence shell. Here radius is very small, so here nuclear pull will be very strong. So when you are adding electron here, because of small distance between nucleus and valence shell, electron will get easily attracted by an atom. Why it is getting attracted? Because the size of atom is small and nuclear pull is very strong. As we move down here, you can see that the radius of an atom or size of an atom is slightly increased. So here it will be little difficult to attract the electron toward itself because nucleus is little far from the valence shell. So here the energy released will be little less than this one. Okay, here due to this short distance, electron is easily getting attracted, and second point is nuclear pull is very strong. Due to small size, nuclear pull is very strong. All the electron is getting attracted by nucleus. So when we are putting one extra electron here, this electron will get attracted by nucleus very easily and lots of energy is released. Here the size of the atom is more, so nuclear pull will be little less, and here energy released will be less than this one. Now here the size of the atom is very big, and nuclear pull will not able to attract all the electron toward itself because the distance is more. Okay, so here when we are adding electron, it is very difficult to attract that electron toward itself because nuclear pull is not that much stronger due to the size, the bigger size of an atom. Nuclear pull will not get stronger because the size of atom is more, the distance between nucleus and valence shell is more. Okay, so electron, when we want to add electron, here it will be difficult. So as we move down the group, electron affinity decreases. Okay, electron affinity decreases. Why it is decreasing? Because the size of the atom is increasing, the distance between nucleus and valence shell is increasing, and nuclear pull will not able to attract the electron toward itself. That's why it is decreasing. So here electron affinity is most and here it is least in a group. Now let's talk about period. When we are moving from left to right in a period, you can see that the size of the atom is decreasing. Okay, so due to decrease in the size of an atom, nuclear pull will be stronger here. Okay, so when we are moving from left to right, the size of atom is decreasing, and due to this decrease in size, nuclear pull will be more in the left side of a periodic table. So here when we want to add electron, it will get attracted by the nucleus very easily because the nuclear pull is very strong due to small size of an atom. Here the size of atom is bigger as compared to this, so the nuclear pull will not get uh, that much strength to attract the electron toward itself due to the size of an atom. Here the size of atom is bigger, so the nuclear pull will be little weaker due to big size, and here the nuclear pull will be very strong due to small size, and if you are putting electron here, it will get attracted by the nucleus very easily. Suppose we are putting electron here, it will get attracted by the nucleus very easily, and after gaining of that extra electron, some amount of energy is released, that is called electron affinity. Okay, that means when we are moving from left to right in a period, electron affinity increases. Okay, why it is increasing? Due to decrease in the size, and here the nuclear pull is very strong. When you want to add electron here, it will release lots of energy, and here it is very difficult to add electron, so here the electron affinity will be least, and in the left side of the periodic table it will be most. Okay, it is clear to you all? Now one note is here that group number 18, that is inert gases or noble gases, have zero electron affinity. Why they have zero electron affinity? Because they form stable electronic configuration. You all know what is stable electronic configuration. That means last shell completely filled valence shell. Okay, completely filled. It may be octet or duplet. Duplet or octet. Okay, for it is duplet is only for K shell and rest of the shell must follow octet rule. Okay, so here in the case of inert gases, the tendency to add electron will be 0 because they already have got duplet or octet. So we cannot add more electron because there will be repulsion between them and the electron affinity will be 0. Okay. This is your homework. Why electron affinity of fluorine is less than chlorine. Okay, now we will move towards next topic, that is electronegativity. Electronegativity is represented by En also. Okay, En is electronegativity. It means that when the electron is there, it will get attracted only, not gained by an atom. It is only attracted by an atom. This is called electronegativity. Okay, see here. The definition of electronegativity is that the tendency of an atom in a molecule to attract sheer pair of electron toward itself. Okay, you have to understand that it is only for a molecule, not for atom. Children, one thing you have to understand here, electronegativity is not gaining or losing electron. Okay, it is just attracting electron towards itself. It is not gaining electron. It is just attracting electron towards itself. So it is only the tendency. It is not the factor. It is the tendency of an atom to attract the shared pair of electron towards itself. Okay, it is not gaining of an electron. Now children, see here in a group what is happening. The size of an atom is increasing down the group, and in period the size of an atom is decreasing from left to right. So we have already discussed so many times that when we are moving down in a group, the size of an atom is increasing. Due to increase in the size, nuclear pull will be not that much strong. So here the attraction power to attract the electron for the bigger atom will be less, and for smaller atom the nuclear pull is more because the number of shell is less and nuclear pull will be more. So the attraction will be more here and least here. Okay, most here and least here because nuclear pull is very strong here and nuclear pull is very weak here. And here the number of shell or size of an atom is small, and here the size of an atom is big. So the attraction power will be most here and least here. So as we move from top to bottom in a group, ionization electron negativity will decreases. Okay, electronegativity will decreases as we move down in a group because the size of an atom is increasing and nuclear pull is not that much strong as compared to the top. Okay, now let's take a period. We are moving from left to right in a period. What we can see, the size of an atom is decreasing. Due to decrease in the size of an atom, what will happen here? Nuclear pull will be very strong due to small size. So here the attraction power is most because the size of an atom is very small, and nuclear pull is very strong because it has to attract electron with very small radius. Okay, so when electron or any other atom will come near to this atom, then the attraction power, the attraction will be most, and when any other atom is here coming near to this atom, so the attraction power will be less here because the size of atom is bigger as compared to this. So nuclear pull will be less here and nuclear pull will be most here. When nuclear pull is very strong, so it will attract the electron very easily, and nuclear pull is when weak, then it will not attract that much strongly all the electron towards itself. Okay, so as we move from left to right, electronegativity increases. Okay, electronegativity increases. That means to attract, attraction power of an atom will get increases. Okay, now children, see here in a group, that means from top to bottom, you can see that hydrogen is on the top of group number 1 and cesium is at the bottom. So the hydrogen atom is here bigger and cesium is the smallest one. You can see easily that 2.5, now 1, now 9, 0.9, 0.8, 0.8, 0.7. Down the group, the attraction power is decreasing. That means electronegativity is decreasing. Nuclear pull is very less here and nuclear pull is very strong here for lithium. Okay, now as we move from left to right in a period, you can see that it is increasing from 0.9, 1.2, 1.5, 1.8, 2.1, 2.5 and 3. So see that it is increasing as we move from left to right. That means the tendency to attract electron is increasing. The tendency to attract electron increases as we move from left to right, and the tendency to attract electron decreases as we move from top to bottom in a group. Now see here, SI unit of electronegativity is no unit. Okay, because it is not having unit, it is just attraction towards shared pair of electron. That's why it do not have any unit, any SI unit. Okay, and for electron affinity, the SI unit will be same as ionization energy, that is kilojoule per mole. Okay, it is per mole, kilojoule per mole, SI unit for electron affinity, and no unit for electronegativity. Okay, clear to you all? Now we will solve some question based on these topics, these two topics today. Okay, now children, one more thing you have to note here is that group number 18, that is inert gases, do not have tendency to attract electrons. Why? Because they already have completed their octet, so they will not attract any pair of electron towards itself. So this one is important note, that group number 18 do not have tendency to attract electrons. Okay, now see here, one question is that this is atomic number given here from 3 to 18. It is atomic number. Okay, and for each atomic number there is alphabet below this, so A B C D to up to P. Okay, so you have to use this much only, means 3 atomic number is A. You will not write lithium. Many students do that in exam also. When they are writing answer, they put A or lithium or simply the symbol Li. So don't use that. If in the question it is given that 3 is A only, then use A only. Don't write the actual element. Okay. See here, which of these have most electronegativity? Electronegativity, most electronegativity. Can you answer me? Most electronegativity? It will be for group number 17. Okay, group number 17 means 7 electron in the valence shell. 9 is 2 and 7, that is 17 group number, and this 17 also 2, 8, 7. They both belongs to group number 17. Just now I have explained in the note that group number 18 do not have tendency to attract electron. So we will not consider these two groups. We will consider group number 17. Okay, now just now we have learned that when we are moving from top to bottom, electronegativity decreases. Okay, so most electronegativity will be with element G. So your answer will be G, and atomic number for G is given here is 9. Okay, don't use your own symbol or the symbol for 9 atomic number. Which one is halogen? Halogen, you all have learned that also. Halogen, that means group number 17 is known as halogen. In the beginning of this chapter, you have learned that group name for each group. So, halogen is present in group number 17, and here 9 and 17 is in group number 17. So, you have to write both. Okay, 9 also and 17 also. G and O. Both are in group number 17. Both are halogen. Now have least electron affinity. Least electron affinity means the tendency to gain electron, and after gaining electron energy is released. So here it will be option I. Atomic number for I is 11. Why I? Because as we move in a group from top to bottom, electron affinity decreases. Okay, so from top to bottom it decreases. Here it will be least, and when we are moving in a period it increases. That's why it will increase here. It will decrease from top to bottom. So answer will be 9. Now children, this one is your assignment based on this topic. Define electronegativity, state its unit. Okay, just now we have discussed unit. Arrange the element of second period in increasing order of their electron affinity. Okay, second period, you have to take second period. Second period means how many shells? 2 shells. KL. Okay, the third one is halogens have high electron affinity. You have to explain that why they have high electron affinity. And one more question I have given earlier in this video. Here it is. Fourth question is here. Why electron affinity of fluorine is less than chlorine? Okay, so these 4 questions are for your assignment. Okay, so you can ask your doubt if you have, or solve these questions. Okay, you have to do this only. We will continue next topic